Let's take a look at another proof. First of all, we have a parallelogram ABCD, and we're also given that there are two angles inside of that parallelogram that are congruent and two little segments in there. Next, EF is congruent to EF. Obviously, that's a reflexive property, something congruent to itself. Next, AF is congruent to CE. Let's look at the parts that were given to us. AE congruent to FC, and the little part here, EF congruent to EF. So hopefully what you can see is we have two segments that are congruent, and we're adding congruent segments to those. So the reason that AF is congruent to CE is because congruent segments added to congruent segments form congruent segments. Next, BC is parallel to AD. Our first statement says we have a parallelogram. We know that opposite sides of a parallelogram will be parallel to each other. Next, let's look at these two angles here. Remember, we just said two lines are parallel. Now we're looking at two angles congruent. That should key us off for those two parallel lines cut by a transversal. And if you look closely at these, both of those angles are interior and they're on alternate sides of our transversal. So let's look for that statement in here. Parallel lines cut by a transversal form congruent alternate interior angles. Select that as our statement and proceed to our next, or for our reason, let's proceed to our next statement. And it says that triangle EGC is congruent to triangle HFA. Well, we just had two angles in that triangle congruent here. And back up here, we had two segments congruent to each other. So we know we got an angle and a segment. And then these two green angles were congruent to each other in one of our givens. So in this triangle here, we have vertex A, this side congruent, and vertex F congruent to the other triangle, vertex C, this side, and vertex E. Therefore, we have two angles and a side, and since the sides are in between those, this would be an angle-side angle. And that completes our proof.